Hi everyone, welcome to the video. Today we are going to solve find shortest safe route in matrix. In this question, you are given a matrix of row cross column length filled with two kinds of element, 0 and 1. 1 is safe and 0 contains landmines. So you cannot step on the cells having value 0. Apart from that, there's a catch. There are two catches that you can only move up, down, right and left, which means you cannot move diagonally. Also, if a cell is marked as landmine, which is with zero value, you cannot go to the adjacent cells of that particular cell. Let's say in this example one, if this highlighted cell is marked as landmine with value 0, you cannot use the path or this or also the this path. You cannot take this. Cool. Also for this cell value highlighted right now, you can it is landmine, so you cannot go its adjacent value cells, which is this one and this one and this one and this one. So adjacent cells you cannot go diagonal, you cannot go adjacent cells of 0 landmine and not even the landmine. So and you have to start from any leftmost column and you have to go till any rightmost column. It is not that you have to start from the top left and go to bottom right. You have to start from any leftmost and go at any rightmost, and you have to return the count of when the shortest path you can do. So in this question, if you start from this path, take ones these ones, then you cannot go this one, okay, this one, because it is adjacent to a landmine. You take this path, then after that you move to this one upwards, okay. You took this path, you came from here, then you took this path, then again you will go further, you'll go further this path. So total you took one two three steps, three steps from leftmost to this one, and three steps, then fourth step you move upwards to this, and then fifth and sixth step you'll move towards the rightmost cell, you move towards the rightmost cell. Okay, so in total you took six steps. Similarly in example as you can see, if you this cell is a landmine and as adjacent cells are also landmine, so you cannot take this path, you cannot take this, and you cannot take this. So there's no possible path through which you can start from leftmost and go to rightmost column. You'll have to traverse through adjacent cells of this landmine, and they are unsafe, so you cannot take that path. So how we'll do this question? I tried this question using DFS, depth first search, but that was giving me TLE. I tried to tweak that solution, but that didn't work. So now I found a way to solve this question using breadth first search, BFS, and that is what I will imply. So first of all, I'll choose the path using which we can take path cells -1, 0, 0, 1. So this I have taken a constructor. Okay, I have to create a constructor first. So what these values signify? If you have solved any question of graph and all, so you know this signifies the path movement, which is left, right, up and down. Okay, left, right, up and down. So if you take one value from the column one and one from the row one, you'll get a path like -1 previous, 0 means current, previous row but current column, previous row but current column, upwards. Okay, then you take 0, which is the current row, and -1, which is previous column, same row but previous column, same row but previous column, which is leftward. Okay, this is how you will calculate the path. Then I will store the rows and columns of mat 0, number of rows, number of columns. I create queue with dq. Queue you can also take, but you have to do manual operations. But dq will save you some operations. I mean, rather than pop, you can use pop left, and you can get many values at the same time, and it is efficient also. Then I will create a matrix, and I will fill every value with, let's say, -1 or infinity. I'm taking infinity. Okay, so I've created a matrix of n cross m, and I've completely filled it with float value, infinity value. Okay, this will take in further as we go down at the last stages. Then I will create two utility functions. First will be to check whether we are in the bound or not. So I will pass two values I and j, cell values, and we will check whether we are in the inside the bound or not. So return, and 0 less than equal to j less than, which means we are currently in the bound. I, the cell value, is greater than or equal to 0 but less than n, and j, which is the cell column value for j, is greater than or equal to 0 and less than m, which means we are inside the bounds. Then again, I have second utility function will check. This will check whether we can take this path or not. So first of all, if this path is valid or not, we'll check. If it is not valid, we'll return false. And this is the unsafe path. Again, if it is not invalid and it means we are within the bounds, then we'll check whether we can take whether the adjacent cells are also safe or not. Uh, When you type something incorrect out of the blue, I mean, you'll have a feeling that you are not doing something correct as it should be. And look, ij correct. Then other path matrix a plus self dot del row. I could have shortened that one, but let it be now. Okay, this path it will stop here. If we can take the adjacent values, which means the current cell plus forward, backward, upward, downward, okay, and along the matrix is also saved. Cool. Not this one. Yeah, no, sorry. Yes, we can take this path. When this path is not valid. And if this is true, then this means this path is not valid, because see, if it is 0, which means we cannot move, and the adjacent cell values will also be unsafe. If that's not the case, it's not 1, which means adjacent values are all safe, then we can take it. Now we'll move to the main function and do the necessary thing. So till now we take the corner cases, see how we can do it. But now we'll implement the main logic. Cell row is I and column is j minus 1. The last column or the rightmost column you can say. That's the case, then append three values I, j, which is minus 1 over here, and then count values. So three values are row, row value, column value. The last one is count, the number of step you have taken. Well, if we can move forward towards rightmost cell using the four possible paths, four possible directions, in that case we'll keep on incrementing the value of count. Okay, I take three values, x, y, and distance. Distance is the count, total distance. Now q dot pop left, q dot pop left. Three values where x is row, y is column, and this distance is the count, number of taken. So these three values. Okay. Now the penultimate check, if the distance from x to y, distance from x to y is greater than the current distance. If distance from x to y is greater than the current distance, in that case we'll replace this distance with the current distance, because we have to minimize the distance. We have to minimize the distance. Cool. I hope you understand that. Okay, in range, or again the path, if check row, then column, this can be taken, this path is safe, then we will append q dot append again next safe path. Again with the distance, we incremented the distance as I told you some time back. If we can, if the adjacent cell value can be taken, then go to that path and think with the increased distance, because we have taken a next step. Now result is float infinity. Result we have initialized with infinity for I in range. This is quite a big question, although it is marked as medium, but the amount of cases it covers and the learning it gives you, it can be between medium to hard, but it's fine. It is a very amazing question. It teaches a lot of things. First, when you have to take BFS one and one DFS, when DFS, when that is very important thing. A lot of time when we learn these concepts BFS and DFS, we confuse and we become build a prejudice that we will use always this one. This one is easier. I mean, both are similar, but so what I've done over here, we are taking the minimum pass for all the we are initialized as a variable with maximum value infinity, root infinity. Then for all the cell values, we get checking from the right side whether we can take this one or not, and we are basing the distance value minimum distance value with the to the result variable. Now, if at the end of everything, if still the result value is float, which means we have not yet found any possible way to traverse from leftmost cell to the rightmost cell, any path. In that case, we'll return -1 because we have not found any path. But if that's not the case, we'll return result. Let me submit and check again. Okay, self is not defined. Okay, okay. Sorry. Person capital letters. Let me pause for a moment. Okay, so I guess when you keep on speaking while you are writing, so sometimes you just ignore basic things. I just written false in all the cases, whether it is safe or not. That was the issue. So as you can see, it did the job pretty effortlessly. But as you can again see, it took me a lot of attempts in order to get it correct. I started with the DFS depth first approach, but that didn't yield any result. That was giving me TLE. I tweaked it also, but that didn't work. So I hope you learned a new concept and enjoyed it. Thank you. Have a very nice day.